Exercise 1.2. So the first question we have here is state whether the following statements are true or false. Justify your answer. We have to read these statements and tell if they are true or false and justify the answer that we are giving. That means we have to give reason as well. Every irrational number is a real number. Real number क्या होते हैं? Real numbers are numbers that are a combination of rational and irrational. जब हम rational और irrational को combine करते थे तो कौन से numbers बनते हैं? Real numbers, right? तो is every irrational number a real number? क्या सारे irrational numbers real numbers होते हैं? Yes, according to what we have learned, all the irrational numbers are real numbers. So a given statement here is true. So we will write true since irrational numbers are a part of real numbers. Moving to the next one. Every point on the number line is of the form root m, where m is a natural number. Okay, so every point on the number line is of the form root m. they are saying क्या number line अगर हम कोई draw कर रहे हैं तो उसके सारे points root m की form में आप लिख सकते हो, where m is a natural number, और m natural भी होना चाहिए. अगर m natural होगा, natural numbers 1 से start होते हैं, है ना? नेचुरल नंबर्स किससे स्टार्ट होते हैं? 1 से स्टार्ट होते हैं. दैट मीन्स कि अगर हम रूट m की फॉर्म में लिखना भी शुरू करें, रूट 5 इफ आई राइट, तो वो यहीं तक के नंबर्स को कवर करेगा, वो यहीं वाले नंबर्स ही कवर करेगा. इट विल ओनली कवर्स नंबर स्टार्टिंग फ्रॉम 1, राइट? व्हाट अबाउट दीज नंबर्स वुड बी लेफ्ट. ये वाले नंबर्स तो रह जाएंगे. दैट मीन्स द गिवन स्टेटमेंट टू अस इज फॉल्स. Every point of the number line is not of the form root m, where m is a natural number. The statement is false since it will not include negative numbers. Next one. Next we have every real number is an irrational number. Real number की definition क्या थी? What were real numbers? Real numbers are a combination of rational and irrational numbers, right? पर क्या सब real numbers, सारे real numbers irrational number हो सकते हैं? सारे real numbers irrational हो सकते हैं? अगर सब real numbers irrational हो जाएंगे, what will it mean? That real number will not include rational numbers, right? Which is a false statement, because real numbers include rational numbers. So the given statement here is false because rational numbers are also a part of real numbers. I hope till here it is clear to everybody. For regular updates, do not forget to subscribe the channel. Next question. Are the square roots of all positive integers irrational? That means अगर हम सब positive integers का square root कर रहे हैं, तो is it necessary कि वो सब numbers irrational आएंगे? Is it necessary कि वो सब numbers irrational आए? Okay, let's start with root 2. Root 2 is irrational. Root 3. Yes, root 3 is also irrational. It is not a square number. Coming to root 4. Root 4 is what? 4 is a square number. Root 4 is equal to 2. 4 is a square of 2, right? So root 4 is what? 2. And 2 is a rational number. what were we asked here? हमसे क्या पूछा था? Are the square roots of all positive integers irrational? क्या सारे पॉजिटिव इंटीजर्स का स्क्वायर रूट अगर किया जाए तो वो इरेशनल ही आएगा? नो राइट. अभी हमने देखा है दैट सिंस 4 इज पॉजिटिव एंड रूट 4 इज व्हाट? 2 इज अ रैशनल नंबर. दैट मीन्स it is not true that the square root of all positive integers are irrational हो ये necessary नहीं है. If not, give an example of the square root of a number that is a rational number. If not, तो हमें example देना है that the square root of a number that is a rational number. तो हम यही example दे सकते हैं, right? So what will be the answer that we are going to write? No, it is not necessary that the square roots of all positive integers is irrational. ये necessary नहीं है. If not, हम उसका example we are giving it. तो we can write examples as, क्या example लिख सकते हैं हम? root 4 which is equal to 2. Then we have root 9 भी ले सकते हैं which is equal to 3. root 16 भी consider कर सकते हो which is equal to 4 and so on. से obviously बहुत सारे examples हैं जो हम ले सकते हैं. Okay. Next we have here is to show root 5 can be presented on the number line. How can you show root 5 on the number line? अब हमें show करना है root 5 on the number line. ये कैसे करेंगे? How are we going to do it? As we have learned for root 2 and root 3, what are we going to do? We are going to draw a number line. I am giving you a rough sketch for the initial understanding. We are going to draw a number line of starting from 0. We are going to mark all the points 0, 1, 2, 3, 4. Then we are going to need a right angle triangle such that the hypotenuse is root 5. Now using Pythagoras, if I am using Pythagoras theorem, what does it say? Pythagoras theorem says that the square of the hypotenuse is equal to the sum of the squares of the other two sides, that is the square of the base and square of perpendicular, right? यही कहती है Pythagoras theorem. According to Pythagoras theorem, the square of the hypotenuse is equal to the square of the other two sides, sum of the square of the other two sides. So what do I need hypotenuse as? I need hypotenuse as root 5. Square of root 5 is what? 5. Now 5 is equal to 0 plus 5. I can write it like this, or I can write it as 1 plus 4, or I can write it as 2 plus 3. Right, now all these should be square numbers. That means zero square, 5 is square of what? Root 5 square. Then 1 is the square of 1. Then you have 4 as 2 square. Moving forward, we have 2 as square of root 2. Then you have 3 as square of root 3. I need a possible combination such that I can take one of the units as base and the other as perpendicular. Right? मुझे ऐसे combination चाहिए which is the most easiest one to be drawn. अब 0 plus root 5, that means one of the dimensions have to be 0. अगर 0 plus root 5 हम consider कर रहे हैं तो एक डायमेंशन को क्या होना पड़ेगा 0 और √5 ड्रॉ करना पड़ेगा। √5 तो हमें ऑलरेडी क्वेश्चन में पूछा है 2 ड्रॉ करने के लिए, तो हम ये कॉम्बिनेशन तो नहीं ले सकते। देन मूविंग फॉरवर्ड आई हैव दिस एज अ कॉम्बिनेशन where I'll have base as 1 and perpendicular as 2, या रिवर्स भी कर सकते हैं, हम बेस 2 लेकर परपेंडिकुलर भी 1 यूनिट्स की ले सकते हैं। सो दिस कैन बी अ कंसिडर्ड केस। फॉर दिस वन व्हाट डू आई नीड √2 and √3, which is again a complicated one. So we are going to consider this case where I take base as, where I can take base as 2 units and perpendicular as 1 unit. To find hypotenuse as √5, so I can plot a point which shows √5 on the number line. अब हम रफ स्केच की अगर बात करें तो हाउ वी गोइंग टू डू इट, इफ़ आई टेक बेस एज 2 यूनिट्स, तो हम यहाँ से यहाँ तक का बेस लेंगे, राइट। नाउ आई नीड परपेंडिकुलर ऑफ 1 यूनिट्स, परपेंडिकुलर शुड ऑलवेज बी ऑफ 90 डिग्री। यू आर गोइंग टू कंस्ट्रक्ट an arc from point 2, cut the 60 degree angle, then you're going to cut 120, make 90 degree here, then you can draw a line of 1 unit from point 2, join these with 0, the hypotenuse thus formed would be √5, and taking AC as radius, you are going to mark a point on the number line, an arc on the number line which signifies the point √5. Now we are doing it with all the measurements. Starting with drawing a number line, I am using the inches side to draw it. To draw √5, we use Pythagoras theorem, right? √5 square will be is equal to 2 square plus 1 square. That means either the perpendicular or the base will be 2 units, right? I'm taking the base as 2 units. I'm taking the base as 2 units. I'm going to draw a perpendicular on point 2. To draw perpendicular, open a compass with any radius, then mark an arc on the number line. What do we do next? We mark with the same radius, we mark 60 degree, then this one would be 120 degree, right? To draw 90 degree, we will be marking an arc from 60 and 120 degree. We have 90 degree angle here. Draw a line segment from 2. The length of the line segment would be 1 inch, right? Till here. Now next what we are going to do, we are going to join 0 with this point. So here we have a right angle triangle with a hypotenuse as √5 and base with 2 units and perpendicular with 1 unit. We are going to take the length of the hypotenuse as the radius, and we are going to draw an arc on the number line which represents, the arc intersects the number line at this point, right? So this point represents √5.